Hello everyone, I am back with another video. So in this video, we are going to see how I implemented TF-IDF scoring. We are going to look the code and we are going to understand with some examples. So in the previous video, we talked about inverted indexing. So inverted indexing, it's all about positional inverted indexing. So what does that mean? Every tokens of the document, it needs to be indexed. So every tokens, they take the knowledge about the document ID and the position of that token in that document. If there are multiple same tokens in a same document, then we just keep the document ID same and we append two different positions like we have done here. And if the token is entirely in another document, then we just append the document ID and position itself. Now let's talk about the calculation of TF-IDF score. So how can we calculate the TF-IDF score? I have written some formula here. So TF, it means term frequency, and IDF means inverse document frequency. So for the calculation of TF-IDF score, we need to calculate TF and IDF for each and every terms of each and every document. So here we have written the total terms in document D. That means that total tokens we got after pre-processing the documents. So this TF-IDF score, it consists of two terms, that is TF and IDF. So TF means term frequency, which is calculated by using this formula, count of the term T in document D divided by total number of document D. What does this signify? It gives the measure of how frequently a term is appearing in a document. So let's take an example. Language, let's see. For TF score, let's count the total number here once and here twice. So the total number of token language in document 3 is 2. So this is 2 divided by total number of tokens. So tokens, it's given by, so this is the first, second, third, fourth, fifth, we remove this, sixth, we remove this, 7, 8, 9. So there are 9 tokens. So we get this TF score. Now what about IDF score? IDF of any term T is given by natural log of n divided by nt. So n is the total number of documents and nt is the total number of documents containing the term. Here the total number of documents is 10. So we can count this and the total number of documents is 10. And for term language, this is only found in this document 3. I can't find any other document containing this token language. So we are just going to take natural log of total number of document, that is 10 divided by total number of document containing the term, that is 1. So we get the result 2.3025. So we just have to multiply this TF and IDF score to get the final score. What does this final score signify? What is the principle of TF IDF score? Why do we find out? So firstly, it's about so what it tells is important words, they appear frequently inside a relevant document. So it's true, if any word is important in that document, then it needs to come like frequently or appear frequently in that document. So the next principle it tells is important words are usually rare across all documents. So if the machine is important for document 0 only, then the probability of appearing machine in other documents is relatively low. So the combined TF-IDF score, it gives how relevant any token is with that document. So, and how rare it is in other documents. So the multiplication of these scores gives us the TF-IDF score. Later in the time of searching and giving the result, TF-IDF score, it plays very significant role because we need to sort each and every search result on the basis of TF-IDF score. So higher TF-IDF score, it generally means that the term is relevant for that document. The TF is larger, or the TF score is larger if the frequency of that term in the document is more, and if the IDF is generally larger for rare words, that is the term it's more relevant to that document, or like the machine is relevant for document 0 and it's not relevant for other documents. So the occurrence of machine is rare in other documents. In this case, the IDF score is larger. So multiplying to larger terms, it's always going to give larger score. So higher score, it's more relevant. Now we are going to look how we have implemented this firstly we need to understand one thing, that how we are going to make TF-IDF table and what is going to be the structure of TF-IDF's IDF table. So I'm going to write it down here. So I'm going to show how it is structured in our code. Okay, so this is the structure of TF-IDF table. So it means that we have to do, so I have already told that we will be computing TF-IDF scores for each and every tokens for each and every documents. So we have to maintain this table on the basis of document ID. So document 0, so this is the document 0, and inside the document 0 we need to have each and every terms or tokens, and we need to write or entry the score of each and every tokens in that document. For other document, so another document ID, that it can be 1, and this can be 0, and term 0, or realistically it can be machine. And for document 1, the term can be like artificial, and so on. So we have to maintain this table for each and every document. So what we will get at last is document ID, that is equal to 9, because we have 10 documents, and it will have terms like big and its score, and so on. So this is how we have implemented the TF-IDF table structure. So it has the length of the document size, which consists of each and every tokens for each and every documents. So now we are going to look how we have programmed this. Let's see what's happening in the code. So firstly, we are calling this calculate TF-IDF score. So before that, we have like built the index, and which we have already done in the previous video, and we are just sending that index and the document's length or size to the calculate TF-IDF score function. So in this we have this unordered map or the dictionary that is in this form. We have already discussed, like each and every terms of each and every documents needs a TF-IDF score. So we will be maintaining this table on like this. And the another is the document length. So document length is basically, it consists of the document ID as the index, and the value is just the total number of tokens in that document. So it's the document length, and we are iterating through all the tokens or through all the indexes. So indexes, it's basically in this structure that we have already seen here, I guess. So here we have already seen it. So we are iterating through that. So firstly, what we get is, for each and every postings, we get the document ID and the term count. So it's basically the count of token in that document ID. So if the document ID is 0, then the term count of that token in that document ID we store in this integer term count. This is document length, is basically, we know this, and in this structure. So what we are doing in this operation is, we are performing the cumulative sum of all the term counts of that document ID. So in this document 0, we will have each and every tokens count after this operation. So now let's talk about how we have implemented this calculation. So here we have this NT, that is the posting start size. That is basically for each index we will be noting the size of the posting. So here in this case, this is the word, the document ID, and the position. This is, so the example is natural, and it belongs to document 0 with position 0 and 1, and the document 1 with position 0. So for each index we will have the total number of document containing the terms. It's basically the size of the posting. So the size of the posting is 1 and the 2. So it belongs in 2 documents. So this is 1. So this is 1, and this one is another. IDF, it's basically calculation of we have already done here, the total number of documents divided by number of documents containing that term. So we have performed the same thing here, and for each and every postings, now in this for loop, what we are doing is, for each and every postings, so this one is the first posting, and this one is the second posting. So the entries, so this one is the first entry, and so document ID is entry dot first, that means entry dot first, and the term count is entry dot second dot size, so it's the positions size, that is the term count. And we can just calculate the TF score, that is a term frequency, that is equal to the term count, that's the term count, divided by total number of terms in that document that is given, that is found after computing this operation. So, and we maintain this TF-IDF table such that the first term is document ID, and we append the terms, and we get the scores. So why did we calculate the TF-IDF score? For searching and giving the relevant result for that query. So we have just calculated the TF-IDF score. So this much for today, guys. So in the next video, I will be back with searching and ranking phase. So this TF-IDF score, it is very important in the next video. So now this much for today. If you like the video, give a thumbs up. If you really like the video, subscribe, and bye until the next time.